Okay, I think we are live. Let me just check. All right, so hi everyone. Welcome to GraphQL Wrocław. I am your host, Marcin Gębala. I work as a backend lead developer at Sailor Commerce. So this is our 5th edition of GraphQL Wrocław and a first online. So we are streaming now from our office in Wrocław. As you can see, we have those nice lights that match GraphQL logo in the back. So this is the first edition that we do after a year of a break, which we had for obvious reasons. And now we are very excited that we managed to bring this idea back to life and find 3 amazing speakers that we have for you today. So before we start, short technical information first about the schedule. We have 3 talks. Each will be like 20 to 25 minutes. And if you have any questions during the talk, you can ask them on YouTube. And after the presentation, we will pass those questions to our speakers. So I think we can start. So our first speaker is Aleksandra Sikora from Hasura. Hi, Aleksandra.
Hi, hello.
So you might have seen Hasura already at many GraphQL events, such as GraphQL Asia, which is an event organized by Hasura. And today, Aleksandra, who is tech lead at Hasura, will tell us about integrating business logic into GraphQL APIs with Hasura Actions. So, ladies and gentlemen, please welcome Aleksandra Sikora.
Yeah, thanks for the introduction, and welcome everyone. So yes, today I will be speaking about integrating custom business logic with, among others, with Hasura Actions, but I will also show a few more ways how to add business logic to your Hasura. So first, a few words about me. So I work as a tech lead or team lead at Hasura. I am managing a team responsible for the front-end part of Hasura. You can find me on Twitter as Aleksandra Says, bureaus on GitHub, and you can also check out my blog, aleksandra.codes. This is my agenda. At first, I will talk a bit about Hasura, what it is, what we're doing there, and then I will move to 3 ways of adding custom business logic. The first one is remote schemas, the second one event triggers, and the third one Hasura Actions. So, without further ado, a little bit about Hasura. So what we are providing instant GraphQL API for all your data. What it means that Hasura can connect to your databases, to your external APIs, external GraphQL services, and provide one unified GraphQL API. This is the front-end application. This is the application that me and my team is building. So this is kind of like a admin dashboard. You have this graphical panel when you can try out your API. You have a data panel when you can have kind of like an UI for your database. You can create your tables. You can view your tables and modify them and so on. You can also configure all those features that Hasura is providing, and among others, the ones that I mentioned before, actions, remote schemas, and events. I will be talking about it in more details in a bit. So this is the front-end part. And what else Hasura provides? We provide real-time GraphQL engine out of the box. That means that we support subscriptions. So if I have this subscription here, and if I do some operations in the background, like on this example, I insert something to the database, and I can see it real time, the new data. The next thing that is important is that Hasura is a compiler. What it means is that we compile GraphQL queries to SQL queries. And on this example, you can see that I'm trying to query users, and from users, I want to query name and something that has relationships with users. This called posts. From posts, I want to query title and content, and another thing that is in relationship, tags, and from tags, I'm querying name. So the SQL query, this is a huge simplification, but the SQL query will be a cross join of those tables from which I query the data that I need. And this is what basically the Hasura engine is doing for the databases. And what else? We support multiple databases. So previously, if you are familiar with Hasura already, we were working on one single Postgres database. You had Postgres database, then you would connect Hasura to it, and then you had like a GraphQL API on top of Postgres. Right now, we added support for adding multiple databases, and in the latest version, we support Postgres, Gigabyte, which is compatible with Postgres, so it was working before out of the box as well. We also support Timescale, which has the same story as Gigabyte. But we also added recently support for SQL Server, and right now we are working on BigQuery. We also have something like Hasura Cloud. So this is like a dashboard when you can manage your projects, and we can host those projects for you. So so this is like a way for hosting your Hasura project. You can also self-host Hasura whenever you wish. This is just an option that we built last year. Then we provide authorization. We provide row and column based authorization. So I'm going to show you quickly how it looks. So I have this table users, and I want to specify permissions for let's say some test role, and I want to say that my test role can have only access to column name because I don't want to expose ID or age. So I'm going to save this, go back to GraphQL, and I'm going to add it to headers. Select this, and you can see that this content of the Explorer kind of changed because right now I have like restricted permissions to my tables, and I can see if I expand users, I can see that there is only name. However, if I deselect it, I can see I have access to everything. So this is just a sneak peek of permissions. Then we recently added something like REST endpoints. So for whatever reasons, the GraphQL migration is not always super easy. And in many cases, you would like to have like, gradual migration, or you would want to, leave some part of your backend as REST APIs, and you would like to migrate some other part of your backend to GraphQL. So right now we support something called REST endpoints. So let me go back to, I have a demo somewhere here. Yeah. So let me see if I have some tables here. I probably don't. So yeah. So anyway, this is the new tab REST here. And what I can do, I can create a new REST endpoint based on the tables I have. I probably can open something else to show you this. This probably should load a bit faster. And I hope I have something here. Yes, give me a second. Okay. let me create something really quickly. Okay, I can go back to my, oh, this is why it wasn't working, because I had row selected. So let me query something. I want to test, and from test, I want ID. Let me name it test, and I'm going to click this REST button, and it will take me to a form where I can create a new REST endpoint. Let's name it test. It's always nice name, and I would like to have it exposed as get. So I create this endpoint, and here it is. I can now use this REST API provided by Hasura next to my GraphQL API. So going back to my presentation, now there will be this part that you signed up for, the business logic with Hasura. So the first thing that I want to talk about are remote schemas. So remote schemas allow you to create GraphQL services with your custom GraphQL resolvers, add them to Hasura, and have one unified GraphQL API. And I think I have a quick demo of that. So let me go to this remote schema page. I will create ads, and what I have for the demo today, I have like a super simple GraphQL layer on top of Auth0. So Auth0 provides this first API, and I have like super simple and only one resolver Auth0 that accepts either EMEA or AD. So I can actually open it and show it really quickly. If Code Sandbox loads fast enough, yes, yeah, it loaded. Yeah, so this is an example query that I can send to this service, and this is the response. And now I'm going to use it as a remote schema in my Hasura application. So let me go back here. It's probably not a good idea to use it in the slides. So I think I have the same application here. So I provide this URL to my Auth0 GraphQL service. I will call it Auth0, and I will add it. And right now I could go to my GraphQL tab, and I can see that there is this Auth0 field. And this is cool, but this is not enough. We can have more. And specifically, we can go to users, and we can connect our Auth0 to our table via remote schema relationships. So right now, I will create relationship, and I will call it Auth0 profile. And I would like to say that I would like this Auth0 ID returned from my GraphQL service that I showed you before. I want it to be mapped with ID from my database table. So I'm going to create this. I have this one row with ID from Auth0, and right now I can query users. And I can get some information from my database, but I can also query the Auth0 profile. So I can query the information from Auth0, say I want to email verified, and let's try this out. Yeah, so here I have information from database, and here I have stuff from Auth0. So this was one thing regarding the custom business logic. And the next one are data triggers. So data triggers, how it works. So you can configure a data trigger in Hasura, And whenever something happens to your database, like you add something to a table, or you delete something, or you update a row, then Hasura will make a request to a specified REST endpoint. So let's see it in action. I will go back here. I will go to events. I probably created already something, but let me go through this process again. So one of the most common use cases for event triggers can be sending email after adding a new row to a database. Like, let's say you want to send email to your user that there is a comment added to the database, or that there is a new user that started using an application that created an account, something like that. So let's call it send email. And I want to say that on table comments, whenever I add something to table comments via any application, I want Hasura to send requests to my custom webhook URL. I have something super simple here. I have like an express REST service with this send email route. And right now it's not doing anything. I just wanted to show you how it could work. So I'm going to copy this, paste it here, send email, and create this event trigger. Not sure if this is hibernated or not, but I have like a super simple page, and this website is basically using the same Hasura that I have here. And what should happen right now? I should be able to add a comment, and I should have it here. So is this the same one that I posted? I don't think so, because it might have been hibernated. So let me refresh this. And I also made a typo in my URL. So let me quickly edit it. Yes. And now let me try again. I can actually paste some more real life data. I will click add, go back here, and yes, I got the comment Hasura on insert to this table comments. Hasura sent a request with this kind of payload to my REST API. And here you can do whatever you want. So this is about data triggers. We have also something like cron triggers. So, so one part of the idea of data triggers is the same. Hasura also will send a request to your webhook, and you can, write any business logic in your webhook, whatever as you want. But this time it will happen, as you specify some configuration. So if I go to events and to cron triggers, I need to specify the cron schedule. Like, let's say I want to send an email every month or every week, or I want to check something and upload some data whenever, every day or every minute even. So this is what cron triggers are for. And another way to add business logic, also something related to triggers, is one-off scheduled triggers. So the same idea as with cron triggers, but it will happen only once. And this is how it looks. You can schedule an event on a particular time, and you can also send some payload. You can specify this payload that will be sent to your webhook from Hasura. So this is it about triggers. Now, the third part of my presentation, the third way to add custom business logic, and the most powerful way to add custom business logic are actions. So what are actions? So actions allow you to extend your GraphQL API via custom queries and mutations. So it's not only that there will be some background call to your first endpoint or some background job done whenever something happens to the table. You can add new mutations, you can add new queries to something that Hasura already generated on top of your database. And how it works exactly. So this create user is an action that I created. This is not something that Hasura generated from my database. This is something that I manually created. I created this action user that takes some payload, and my idea behind it was to do some more complicated logic on the backend before actually creating a user, and hence I wanted to do it as an action. And then Hasura, based on that, has some payload, the payload that is going to send to your REST endpoint. And there are two modes of actions. First one is async mode. So basically, you call your custom query your custom mutations. Hasura will capture it and will store it in event store. And then Hasura will be pulling those events from event store and will be calling all those endpoints that were specified in every action that was stored in event store. In sync mode, there is no event store, there's no intermediate step. You call your custom mutation or query, and Hasura directly sends a request to your webhook. And now, how we are receiving the responses from the webhook. So in the async mode, Hasura is like putting them back in the event store after calling the webhook. So whatever webhook returns, it will go back to event store so that we can look it up later. In sync mode, Hasura will keep the request open. You send the query, Hasura sends something to your first endpoint, it gets a response, and you get it right away. So in the async mode, when you want to actually check the response, get whatever was returned from the webhook, you need to ask for it. Probably you want to use subscription to wait for the result to be actually updated. And in sync mode, you call your custom mutation, the same create user example, and you get response from your custom mutation right away. And on top of that, you can also take whatever you want from the database if you specify relationships between actions and tables. So so it might have been a lot. So let's see it actually in action. So let me go back here. I will create a new action. By default, I have a mutation, but let's try with query. And let's call our action login. And my argument is some user input. Let's call it that way. And just for the sake of an example, I will leave whatever it is as it is. So I won't be changing those types. And now, in the same way as in case of events, I need to specify some handler that is supposed to be called whenever I use this login query. So I also have it here under super simple handler that basically only returns this access token that is supposed to be returned from this action. So let me copy it again, paste it here, login, and this is our action. So now I can go to the GraphQL tab, and I can see that here is my custom query that I just added my action, and I want my access token. So I can run it, and I will see this this empty string, and let's add something here to just see if it works. I will run it again, and yeah, I have the string that I just updated. And what's more is that you can also specify permissions on the actions. You can, for example, say that a role called user shouldn't have permissions to this action, and so on. And what's also quite interesting is that you can specify relationships between your action, the output type, and any table in your database, which can be also, pretty useful. Like, let's say if I would like to extend this login, and on calling the login, I would like to connect it with, let's say, a users table, and on login, I would like to fetch more data about the user. So this is one example use case. And that was it from my side. A few links that you can check out. So I encourage you to check out the Hasura.io website. You can find some tutorials, docs, and you can also find more information about adding custom business logic and different use cases for it. And you can also check out our open source repository on GitHub, Hasura/GraphQL-engine. And thank you all, and thanks for having me here today.
Thank you very much for your presentation. So it seems that although I have no experience with Hasura at all, it is a pretty powerful tool, and actually what you showed with actions kind of reminds me of what we are building currently at Sailor, because we are also thinking about how to add custom logic that people have in their e-commerce platforms without extending the source code of the platform. And we do that with webhooks. And for example, currently we implement synchronous webhooks for payments. So it looks pretty similar to what you have with synchronous actions. So let's see if we have any questions. So there is one question from Damian. Can we export or import GraphQL queries or mutation with Hasura?
I'm not sure what you mean by export or import, but if you mean that whether you can kind of like, apply a bunch of actions to a new Hasura, like apply a bunch of new queries or mutations that you created in another Hasura with actions, then yes, you can do this by calling a proper API and updating the underlying metadata. But if you are asking about how to write queries or mutations, then you can use introspection API as with any other GraphQL service, and you can possibly generate types and so on. And you can use any other tool, not only GraphQL, but any other GraphQL Explorer. I'm not sure if I understood the question, so I'm sorry if I didn't answer correctly.
Okay. So do we have any other questions? Yes, from Jakub. Can we use Hasura to federate existing GraphQL services? So let's hear about federation at Hasura.
Yes, you can. You can do this via remote schemas. You can add remote schemas, and you can create relationships via remote joins. So yeah, that's possible.
Cool. Do we have any other questions? I think we don't.
I just realized that it's pretty dark.
Yeah, it is.
Sorry.
Right. So once again, thanks a lot for your presentation. I think that you can share the slides on the meetup page, where you can send them to us, and we will share them as well. So thanks again for having you. Great presentation.
Yeah. Thanks a lot for having me.
So we will continue with our schedule, and right now we would like to quickly tell you a little bit about open positions that we have at Sailor and Mirumi, which are organizers of this event. And as you can see, these are separated into two columns, and the reason why is that Sailor and Mirumi are actually two separate companies now. So people who maybe know us, this may be something new for you. So the reason why that happened is that Sailor actually is growing pretty fast, and there was big news recently that we are very proud about, and the news is that Sailor raised $2.5 million in seed funding. So we are basically growing our platform and the team behind the platform. So as you can see, we have many open positions. We look for front-end developers, DevOps engineers, and many other roles. So if you want to work with the product and with open source software, you may be interested in applying to Sailor. If, on the other hand, you would like to work more in a software house which does individual projects for individual clients, then maybe you might be interested more in working at Mirumi Software. So if you want to check those positions, then go to our websites and feel free to send us an email. So now we can continue with our second talk. And our second speaker today is Luca Ferrari. Luca Ferrari is a senior solution architect at Red Hat. So he's actually our second speaker from Red Hat, because we had one on one of the previous editions. And today Luca will speak about how easy or hard it is to monitor your GraphQL service performance.
Hi, everybody.
Luca,
can you hear me?
Yep.
Yeah. So I can see a glare from the sun. Most likely I'm at sunset. So a quick intro on me before we start. I believe you can see my presentation, right? I guess so. Just to give you an idea of my background, I have a longer background on REST services and REST APIs. So I was basically working for a startup in the API management field that got acquired by Red Hat, and now I'm working with let's just say integration technologies. So I'm basically looking at the different ways and protocols that you can use to basically let two systems communicate with each other, and that's one of the reasons I started getting interested to GraphQL. So bear with me, I'm not a huge expert in GraphQL, but I'm trying to get the speed up on some details on this, but what I'll present today is really around a general overview of what are the challenges of GraphQL as compared to your typical REST API, possible solution to a specific issue. Then we'll see a demo covering a specific problem, and then we'll have time for some Q&A, basically. So starting just from the basics, I'm pretty sure you all know a little bit the definition coming from the organization website. What I highlighted for my own, let's just say for my own understanding and my own guideline is what are the peculiar and very important aspect of this as compared to your typical REST service. So in this sense, GraphQL is both the query language and the runtime, and it provides a fully understandable and complete description of the data. So this means that it offers really a powerful contract between what is the client and the server. This also means that in some sense, it can be compared to SOAP and to the way SOAP used to work. And most importantly, it allows for always evolving API as compared to what happens with REST APIs and with the API definition. So from all of this, you can see that you get greater power as a developer and also as an end user, because you can basically build your own query. But this also comes with greater responsibility. So this is not from originally from Spider-Man movie, but it's actually from Voltaire. And this is very true because you can basically build whichever query you want, and this gives you potentially access to the whole backend. So this is one of the very important aspect that differentiate this from your typical REST service. So basically, we're switching from this approach to this one, right? As you can see, GraphQL is really language agnostic and is also protocol independent, so it can run also over not only on HTTP. Let's just go through a little bit of what are the advantages that I was mentioning also at the beginning. So first of all, of course, the exact data fetching. So as we can see, oftenly with REST services, we generally run into an underfetch or overfetch problem. So the client might get not all the result he expects while interrogating the REST service, or get too many results, meaning too many details that are really not needed with the query. In this case, you can build your own specific query and get exactly what you need. This is also very important in terms of mobile client, of course, because you can fetch exactly the needed information, meaning less payload through the wire. The other important element related to this also is with one request, you'll get a complex or composite result, which also result in higher network efficiency. So it's highly related to the previous one. And this compares to what happens typically with a REST API, where you need to build multiple queries to get composite result, and you might even need to have an integration in between your REST API and the actual client to actually rebuild the result. This is also highly inefficient because you're running multiple queries, and sometimes you might not even need all the single items inside the list. The other advantage is also the fact that given that you're allowed for schema stitching and you can build a general GraphQL schema, now the same API is usable by multiple clients with different queries. This is super important because the typical approach for REST services is actually multiple APIs for an omni-channel approach or multiple API gateways. So this again, coming from the REST world, is one important highlight. And finally, the field level deprecation. So a topic that I was often discussing with customer across the world is the approaches to versioning, to deprecating certain resources inside an API, and in general, how to keep the documentation update while you're developing a new version of a REST API. So unless you have a really well-oiled CI/CD pipeline with and developers actually respecting the rules around publishing OpenAPI specification, then some specification will fall into the crack of this, and some developer will see a version of the API which is broken or returning an unexpected result. So with GraphQL, you can actually deprecate single fields, which means that it's way easier to manage new version because you're really evolving the schema continuously. And given also how important or how central is the schema in the whole architecture, that's always up to date. Of course, having a single endpoint basically as an entry point has some issues. So these are some of the challenges that you will run into when you're starting to expose a GraphQL service. Some of them have already been tackled through workaround or are being tackled. So, for example, caching with REST, of course, you get different resources mapped by different URLs, which means that you're able to cache at a resource level. In GraphQL, this is more complex because you don't really know the query before it's getting executed. But for this, I believe there is already some solution. So preloading or prefetching the data might help you here. Then you have in general the issue around query performance. So you might want to, in some way, limit the depth of the query because it could be that once you're opening your GraphQL service to the external world, you get random users, of course, and this might decide to just see how reliable is your backend and might even bring your system to knees if it's not well built, let's just say, or in a shape. Then we have security. So the whole OpenID Connect and OAuth authorization and authentication is quite tightly coupled, I would say, with the REST architecture. And there's a whole set of RFC that might not be as easy to apply to a GraphQL service. At the same time, you also have rate limiting, which typically comes with an API management solution, which might not be as granular as in the case of an exposed REST service. And finally, performance monitoring. So typically, if we just measure the GraphQL endpoint, the response time of it, we don't really get a lot of insight into what's the actual health status of our API, because basically the query can vary a lot, and we don't really even know the backend here. So let's just give you a little example. So imagine that we have an internal user or developer that's just executing a simple query, as we see here in the first case, and now public developer comes in and we exposed our GraphQL API externally, and really he wants to retrieve the first 1,000 friends. So clearly the two queries are not really that different as we've seen in the structure, but the second one will most likely see a much higher response time. And of course, response time might be determined by the complexity, but not only of the query, depending on where is the data coming from. So for example, if it's coming from different tables, if we are mediating SQL, or it is coming from different sources. So it might even be coming from a database and a file. So in general, what we're really looking for is the standard behavior given a comparable workloads in terms of queries. So we're really interested into monitoring not the endpoint, but the queries. So here comes the topic of performance monitoring in this sense. So in terms of REST monitoring, typically we speak about observability. So this is defined as the ability to determine the internal state of a system by looking at just its external outputs, so without knowing a lot of its internals. And it basically, in practice, in software, it consists of three pillars: so metrics, traces, and logs. So once you draw the information from these three sources and combine them together, you're basically able to troubleshoot much faster and find bottlenecks in your code or in the calls. And so getting back to the three pillars, so we're gonna focus on traces. Distributed tracing is basically a way to that's used typically in microservice architecture to actually pinpoint where a failure or a delay is occurring in the chain of calls. And open tracing is an open approach to distributed tracing. So it's basically an approach where you have a set of API specification, frameworks, and library, and you basically, as an end developer, you can instrument your application with these libraries, which are using these APIs to actually implement open tracing, and then use the tools you see here on the right-hand side to actually perform or analyze the tracing of your microservices or applications. So just a brief digression, maybe you have heard about OpenTracing or OpenCensus. They now recently merged to form OpenTelemetry. So basically, you will most likely hear in the future just about OpenTelemetry. Just a quick news. So one of the tools that we saw here that is actually implementing the OpenTracing API as a monitoring tool or monitoring platform is Jaeger. So Jaeger is a product that was built at Uber. It was donated to CNCF and has a lot of libraries supporting several different programming languages. It also accepts spans, so basically traces from Zipkin, which is another distributed tracing platform. So this, to give you an idea, is an example of the Jaeger platform exploded. So you typically have your own application, the Jaeger client. So this is the library. So this is actually let's just say a containerized example. So in this sense, the Jaeger agent, which is the one collecting the traces, is actually running inside the same container, but it could be running outside. And the Jaeger agent is receiving the spans, so the traces generated by this client, this library, and is then sending them to a Jaeger collector according to a specific or configured sampling. And then eventually you have the aggregation of this into a database, and then you have a query engine that runs on this consolidated data source with a UI where you can actually visualize the precedence and the timeline of the different traces. So just to give you an idea, this is how it works in practice, so how the traces are generated. So this is the library. In this case, you receive an HTTP request, and you basically are adding a trace ID to the header of the request, and just basically extending the trace. So so that it's all the systems or the application in the chain will collaborate on the same trace ID. So possible way to actually implement tracing inside GraphQL are available. So the first one is a little bit or tightly related to actually your runtime or for GraphQL, so in this case Apollo. And there is an extension that allows you to actually perform tracing directly inside the response. So as you can see here, for example, this is part of the response, and I'm getting data about how long it took to get part of the query. Then you have the possibility of using Instana. So we will see that we have other typically cloud tools here for monitoring. So this offers out-of-the-box tracing for GraphQL on several programming languages, and you are able to explore the traces inside the monitoring dashboard. Then you have Datadog, which provides OpenTracing or a tracer library, which is compliant with OpenTracing. So this not only covers GraphQL, but other protocols and technology. And then you have New Relic, so this is similar to Instana approach. Again, you have the possibility of drilling down into the query and actually checking the distributed tracing information. And finally, so this is what we'll actually see today in the demo that's coming up. You have the possibility with Apollo to use a plugin which is compatible with Open Tracing. So you will find this on GitHub, and request and field resolver are traced out of the box, and queries and results are logged. You can also customize completely the behavior according to what fields or what requests do you want to trace. This is, as I was mentioning before, Open Tracing compatible. This means that you're not forced to use any specific tracing monitoring platform in particular. So today I'll be using Jaeger, but you could be using Zipkin, for example. So, quick intro about the demo. So Apollo Server is basically an open source GraphQL compliant server, and it can be run as a standalone or as an add-on to Node.js middleware. So in my demo, I'll be using Apollo Server with Open Tracing plugin, React.js client, which is also using the Apollo client libraries, and then the Jaeger platform, which we saw before. So this is basically the architecture of what we will see. So I will hit the local page from the React.js client. This will hit the Apollo server, which will use Axios to actually translate the GraphQL query into REST queries towards the GitHub REST API. And in the meantime, I will be sending the traces to a local Jaeger platform I'm running on my machine. So all of this will be running on my machine, with the exception, of course, of GitHub. Okay, let's switch to the demo. So I have my React.js page here. Let me just stop the Apollo server. Let me start again this. Hopefully the demo gods will assist me. Okay, so we see that I initialized Jaeger tracer. I have the server ready, and my client hopefully should be ready. It is. So I will hit this. It is loading the result, and it is loading and presenting some GitHub user with the avatar and the user ID and the link to the user profile. So if we go back to the server, we can see that we generated, beside the GraphQL response, we generated spans for each of the user that was for each of the user and the field that was interrogated, and we can see this inside Jaeger. So if we go back to find traces, yeah, this is from right now, basically. So we can see here, if we expand, that we have the root trace with the request and the query with the called users, and then the different field used in the query. And clearly we can see that it took quite a long time because it is basically sequential. So it's calling the REST API multiple times. So again, we can see the advantages of actually using GraphQL also for your backend instead of using for a composite result REST APIs. And as you can see here, we can see how much time was spent on each of these fields. So this is quite useful if, for example, besides tracking and tracing the GraphQL endpoint, you're also tracing the actual backend. So in that case, you would be able to see where the latency is coming from. And just to give you an idea, some messaging platform like Kafka and RabbitMQ are already supporting distributed tracing. So if you use that as a backend, and I believe also some databases are also, you can instrument them with the open tracing libraries. Sorry. So this is, I just explained what happened in terms of the actual flow and what were the calls. And so let's switch back to feedbacks and comments on this.
Thank you, Luca, for the presentation. Let me quickly check if we have any questions. I think there are no questions, but so I will have one, maybe not a question, but rather a comment. So first of all, very comprehensive presentation, like covering also some of the good things and bad things about GraphQL, as well as the all performance topic. So I can just comment that we at Sailor in our e-commerce platform, we do use Datadog currently in production, and I think it's working really well for us. And in the past, we were also using like locally for the dev team Jaeger for example, optimizing the database. So we were using that to show what were the database requests and if there are any duplicated requests, and that would help us to optimize that. So we currently use those two tools. I wanted to ask if you have any experience with Apollo Engine, or if you heard about that one.
No, I know. So you mean the analytics through the Apollo like enterprise version, I just say?
Yeah, I think this one. So I haven't used that, but I know that Apollo has their own platform for performance, the Apollo Engine, and like they had this dashboard where you can actually see what queries are used in your front end, or you can see if there are like which queries are used the most often, which are not used. So you can learn if, for example, a query can be, deprecated in the future, or how often it is used, stuff like that. And there was also very nice integration with VS Code editor, where you could have from Apollo Engine in your editor estimated time of a request when fetching a query. So this was pretty powerful, but I've never used that. So I was just wondering if you have any experience with that.
I don't. I try to set that up. You basically have to, as any of those tools, provide a key to authenticate to the service in the cloud. What I like. Okay. We got a question actually.
Yep.
Let me just finish. So honestly, coming from a Red Hat and open source perspective, I like much more the open tracing approach, because then you can move Jaeger on-prem if you want, and then manage everything locally. Maybe it's not as complete as the information you would get by be a specialized tool on GraphQL, but at least you get flexibility in that sense.
Yeah, so we have one question. Is there a tracing tool that can be integrated with GraphQL Ruby? Do you have anything about that?
Exploring that, actually, I believe Ruby has their own libraries around GraphQL and open tracing. So you could be using directly that, and basically what you're doing is you're configuring a tracer inside Ruby, and the tracer is inside basically your GraphQL backend, and then it sends the trace directly to Jaeger.
So I think that you only depends on the framework, because I'm not familiar with what are GraphQL frameworks in Ruby. I'm only familiar with JavaScript and Python. But I think that like open tracing is a very general protocol, and it should be available in many technologies, right? So it's just a manner of integrating open tracing basically, and you should be good to use all of those platforms like Datadog and stuff like that, right?
Yeah, you should be able to, although it depends on how flexible it is the library in terms of where you're starting your trace. So if you can pick up the field in the query, for example, or not, because for sure you can pick up the general HTTP query, but then you want to detail about the fields, right? So
yeah. Okay, so I think that's it. So thanks again for your presentation, and I encourage you to share the link or either on Meetup or with us, and we will share it with the community. So thanks for the presentation. Up next we have Krzysztof Wolski, who works at Sailor Commerce as developer relations engineer, or as we call it internally, developer happiness. Can we have Krzysztof on screen? Yes, there he is.
Hi, developer Krzysztof. Happiness doctor is here. Hello, everyone.
Yep. Before we start, I'd like to quickly ask you, what are the hot news from the Sailor frontend team? What are the new features that are coming on the roadmap, or new hot technologies that are you planning to use in the nearest future? Can you share some details about that?
So we have pretty big plans. So right now we are rewriting our storefront part with Next.js. So there will be some tooling around with server-side generation and stuff like that. On the dashboard part, we are starting to create a new UI component library, which will be used internally for dashboard. And also we want to share it with the developers of apps, so they will have the same look and feel as our own dashboard. And in the last part, we are creating marketplace, where developers will be able to create their own apps and share with the other people. All our apps are using React, TypeScript, and GraphQL, so stack is pretty neat.
Yep, that sounds very exciting. So I'm really excited about, because it's going to happen very soon. I think like in a month or so, we are releasing the Sailor 3.0, and I cannot wait to see it live, because this will be the best solution, the best version so far. All right, so I think we can go with your talk. So Krzysztof will tell us a bit more about integrating Sailor with third-party services with Sailor apps. So please welcome Krzysztof and go ahead.
Okay. So I wanted to tell you why I'm excited about Sailor apps. So for the record, I've been in Mirumi for 5 years, and I've been doing pretty much a bit of everything. I started as a backend, then I played with DevOps, then I changed to front-end part, and right now I'm a dev relationship developer. And I really like to play around with tools for each of those parts. In my presentation, there will be lots of memes, so be prepared, and also cats. So let's start with the problem we have with Sailor, or rather we had. So Sailor is a headless e-commerce platform, which is totally open source. You can configure it, it's really flexible, and you can host it however you like. So the main part is a backend part, which we call core. It's application written in Python. We are using Django framework, and GraphQL layer is powered by Graphene. Frontend parts are written in TypeScript, and they are using React and Apollo client, both dev.NET storefront. And the last thing which is emerging is our software as a service, which we call Sailor Cloud, where we will be hosting our API, and clients will bring their own front end, and we'll be creating shops for them. So at Mirumi, we tend to choose bigger clients where we establish long-term relationships. These are mostly big companies, which has shops in many countries. They sell in many currencies. They use a lot of different payment gateways. There's also complicated warehousing and shipping methods. And also, every one of them has different CMS. So we have to find a way how to long-term maintain their projects. And what we used to do is a forking approach. So we just clone the repository, take developers and requirements, and we start changing it. If you know the code base, then it's easy to start, and you can change everything you want, however you like, and what your client needs. But it has few cons. You need to be very precise with your Git history. Also, you need to document what you've changed in your fork, because when there's some new person in your team which has only experience with open source version, you have to synchronize what's changed and why. Also, sometimes there can be changes in the upstream which may affect your code, your changes. So you have to consider that, how to plan your features to be easy to change in the future. And updating process also needs some time. So we have to take that in consideration when you plan budget with your client. And we all know how maintenance is easy to take with clients. And most important thing is it won't work for our Sailor Cloud. We will rather not allow users to run their own code on our servers. And we have two solutions to address that. First is the plugins. Created internal API, which is documented, and developers can, using that, create their own plugins, which will be run on their own servers. And there are apps, which are cooler, I think. Those are separate applications which are communicating with the core using webhooks and GraphQL API. And at this point, I wanted to give a shout out to Maciej Koryciński, who is right now working on new features for our apps. He's our founding father. Okay, so like I said, you can have multiple deployed apps. Some can be just consumers of webhooks of those payloads. For example, for reporting, when you have to synchronize with stocks, you need to be a middleman between core and external service. You can also use app just to add more data to your models in Sailor core. So what's interesting, Webhook Manager is also a Sailor plugin, and it's just a pops up where manager registers apps and topics they want to listen to. So those events could be, for example, that checkout changed, products are modified, there are new accounts, stuff like that. And when those events occur, there are two ways. First, which is already implemented, we asynchronously call apps and inform them about the changes. And Maciek is working right now on a new interface which will allow you to create synchronous apps for example, payment gateways. So you want to create app. So first thing you need is a manifest file. It's a file which describes your application. There's a list of permissions. Sorry for my cat if you hear him. It has lists of permissions, so application are a restricted scope of data of your server. And there's also sections for legal documents and URLs for configuration view. We have possibility to display configuration view in our dashboard as an iframe. Also, your app has to expose at least one endpoint, which is register, which core use to introduce yourself. Token is exchanged and app is added. So security, like I said, we display configuration views in our dashboard. And if user interacts with those components, we add user's JWT token to the requests. So your app can validate that user has this needed scope for changes. And regarding webhooks, if you want to be sure that you are not running requests from unwanted clients, during the webhook registration, the secret is exchanged. So if Sailor sends any payload, we add secret, so you know it's a right API. Like I said earlier, apps have defined permissions, so they have only access to the scope you need. And you can also deploy your applications in your own private network, so those won't be exposed. And I got really excited with apps because that sounded cool. So the first app I've created was Algolia integration for one of our clients. Algolia is a pretty powerful search provider, which has a great UI and dashboards for defining the needs of the search. And we wanted to push their data about products and pages and other CMS data. And that's how the dashboard in Sailor looks like in the apps section. At the top, you can see the application we are talking about. So if you click on it, there's a preview how the configuration view can look like. We decided that in this application, you can change tokens for the Algolia. So you don't need to set it up in, for example, environment vars. And you can change dynamically list of languages. For example, you want to send to Algolia. Also, we added buttons for reindexing all the products if needed. And there's another view where you can check the permissions for the app, read about data policy of provider of the app, and short description. And on the Algolia side, that's how those data look like. You have a lot of switches you can choose and define how to make your searching experience more relevant. In this app, we choose Python as a language, and we wanted something small and fast, so we used Fast API, which is really fast web framework. It supports async. It's really easy to get into. It's similar to Flask, I would say. And the first version of application was delivered in days. We probably spent more time deciding about how do we want to deploy it, because clients wanted to choose different platform that we have our Sailor. And it wasn't any problem, because from the apps and Sailor perspective, you can choose whatever platform you want. You can choose even serverless, which could be very cost effective. And I was pleased. That application was success, very fast. Everything was working, but then client wanted to add more data. And that data was not in the payload. So we have to regroup. Thankfully, we have GraphQL, so we didn't need to create new REST endpoint. We didn't need to change anything on the backend side. We just rewrite our application. From the payload, we were taking IDs of products that changed, and we fetched all the data we needed. We had a whole API exposed, so we could use whatever we want. Pricing, translations, everything was there. To parse responses from the server, we used a library called Marshmallow to ensure it's with the schema. And it was pretty much refactored in one session. It was easy thing to do. And that was big thing for me, because it proved itself. Maintaining that was really easy. There's a small scope of the application where any developer can go through in the matter of minutes. There is no need of checking out all the changes you have in your own fork. You don't need to take into account any things that are specific for this project. This application could be plugged into any other Sailor application. And one of the situations really opened my eyes when we had an issue which we had to debug. And to do that, we just started local environment on our machine. We use ngrok to expose it to the outside world, and we install it as just a normal app on the production, and we could use any debugger we liked. So that was easy to fix. And after this Algolia app, I wanted something more. I wanted to play around with new tools. So I decided to write little application for translations. We have translation dashboard in our dashboard, but clients sometimes use external platforms like Transifex or POE Editor, and I choose the POE Editor because it has generous free dev plan and API looked good. Writing in Python was okay, but from the work on the front end, I've seen how cool it is to have TypeScript compiler shouting at you when you are writing bugs in your code. So I wanted types, so TypeScript was chosen for this project. And since there will be configuration view, so I need some front-end framework. But I wanted to play around with Next.js, which is not only for the front end, but also supports writing APIs and server-side code. And I really like their examples repository. It's a great starting point to just integrate Next.js with any CMS, any service you like. And it blew my mind how things look like on the JavaScript, TypeScript part. Apparel client is very easy to use. It's a very powerful client. It has configurable caching. Using query hooks on the front-end part is so easy. And also you can use it on the server part for example, server-side rendering. Speaking of tools, VS Code integration is great because there's a Apollo plugin which can read your queries you write in your TypeScript. It can, if you use Apollo server, you can even have annotations how long particular fields are executing. And the last thing which made me the most excited was CodeGen, GraphQL code generator. You write GraphQL and you get fully documented TypeScript. If your schema has good descriptions, then you will see those in the TypeScript code. It has many plugins. For example, for Apollo hooks, you don't need to anymore write boilerplate for typed queries. It can be generated automatically with documentation. And there's also helpers for server-side rendering with Next.js. There's a screenshot of the code of application. There's a webhook mutation in GQL tag. As you can see, it's a TypeScript, so you can import fragments from other files, and those fragments also are compiled to the classes by CodeGen, and you can reuse them also in your logic. Here's another view of the registration view. As I mentioned earlier, we have TypeScript, we have Next.js, which is async. So we can return response to the user early and do other things on the backend to not keep him hanging. The mutation I use is fully typed, so every variable I would like to pass to this mutation is typed. The enums are also generated, so there's no chance for any typos. And there's a preview how the introspection look like. You have full knowledge about every field in your code. And I had really a lot of fun implementing that. So takeouts from those apps I've already created. So GraphQL it works great not only for front-end side where you can query whatever you like, but also for communication between applications. And app architecture leads to small designated apps, which are really easy to maintain, really to port to another project. And you're not tied to any ecosystem. Choose any language you like, even the most obscure ones. Choose whatever platform you would like to deploy. There's no difference for us. We can handle everyone. And I've made a little QA for the end with myself. So if you're interested in writing apps, and there's a repository I've created, it's a simple repository. We'll be working on implementing more examples. And documentation you can find at docs.sailor.io. So this question was asked earlier, if we can extend API. So here's the Apollo Federation, which would allow that. And you can also choose Hasura for schemas teaching to solve this problem. I recommend their blog. They have nice posts about how to pull it off. And few tips for creating apps. Embrace asynchronous execution, return early, and you can handle long-running jobs without blocking the client for the response. It's very important, especially if you communicate with external service and you need to wait for a response from them. I would advise to create some kind of logging in your dashboard view. It's really good to know that everything is working as intended or if there are any issues. So a little bit of logs will make your life easier. And if execution any of the jobs is crucial for you, don't just use event loop, use proper queue like Amazon SQS. And the last thing, metadata. Metadata and Sailor are key value dictionaries, which we have in many of the models. Part of them is private, which means that only staff users can use them, and also apps. And there are private metadata, which can be queried by everyone. So you can add, for example, more descriptions for your products if there's no field in schema, which would you like to see. You can use metadata to synchronize few apps between them and have all the source of truth in the Sailor. And plans for the future regarding of apps. Soon we will have asynchronous apps, so you'll be able to create application for new payment methods. Also, it will be useful for creating different shipment providers. As I mentioned earlier, we will be preparing the marketplace where everybody could publish their own applications. And we are working on developer experience with creating apps. So there will be new repositories with starter packs, and we are planning to add some kind of logging to the apps in those. And that's it.
Thanks, Krzysztof, for your presentation. Was that the cut that we heard during your presentation that you showed on the last slide?
No. That was the second cut. I'm surprised this one was so loud. I'm sorry.
Yeah, no problem. He had a lot of comments about your presentation. Actually, yeah. So do we have any questions? So yeah, First question from Michał. What is the name of the second speaker that we heard in the background?
Okay, that was the nachos, and the second one is called, the white one is called XOR.
All right, so now to more serious questions. We have a question from Marcin. Apps sounds great. Have you thought about using AWS Event Bridge for extending integrations?
I haven't read much about Event Bridge, but we can, our applications can use webhooks, which are HTTP requests, but also you could subscribe to a queue channel like SQS. And I've read that Event Bridge is also using SQS, so it's really familiar. Maybe it solves the same problem. So maybe we are faster than Shopify with their apps.
Cool. So I'm not familiar with Event Bridge as well, but as you were presenting, I'm not sure if that was mentioned, but I was wondering if you could serverless to build Sailor apps, for example, like AWS Lambda, for example.
Of course. You can choose whatever platform you like. So serverless could be good for something which is not called very often. So you won't be paying for the idle time of your server. Just you can create API using serverless, and it will be handled just fine.
Cool. Okay, I think we don't have any more questions. So thank you, Krzysztof, for your presentation. So that's it. That would be it for the 5th edition of GraphQL Wrocław. So now I want to thank all the people that joined us today, and thanks to our amazing speakers, to Aleksandra, Luca, and Krzysztof for joining us today. So, as I said at the beginning, we are very happy that we brought back to life this initiative. So we are planning next events. So if you would like to present something that you are working on, anything, then just send us a message. You can find a link to a form where you can submit your talk on our meetup page. So make sure to follow us on Meetup and on our websites for updates. And I hope we will see each other very soon. So once again, thanks a lot and see you next time.